Good morning, students. Welcome to our online classes for class 10 mathematics chapter 2 sets. Welcome to day 3 class. Once recall yesterday what the topics we will discuss. Let's say one by one. What did you remember? Yes, intersection of two sets, disjoint sets, universal set, subset, right? These definitions yesterday we discussed, and based on those definitions we have given a homework also. Hope everyone you might have completed the homework. Did you all complete it? Yes, good. So under day 3, let us see some definitions. Yesterday we have discussed about intersection of sets. Today we are going to discuss about union of sets. Listen the definition. The union of two sets A and B written as A, U, B. Here U represent union. We know the symbol for intersection, that should be reverse of U. Here U symbol is known as intersection. The union of two sets A and B written as A union B is the set containing of all the elements which are either in A or in B or in both. For example, some elements are present in only the set A. Some elements are present in only in the set B. But some elements are present in both the sets A and B. Even though some elements are present in both the sets, we consider them, that means the common elements we consider them as for one time. We don't want to write for two times. So what the elements from both the sets, we should combine all the elements. So clearly thus A union B, we are writing its set builder form. A union B is equal to X such that X belongs to A or X belongs to B. Clearly, if there is an element X which is in A union B, which implies X belongs to A or X belongs to B or X belongs to both A and B, what we call A intersection B. Let us see here one example. A is equal to set of all A, B, C, D. B is equal to set of all C, D, E, F. Here we are asking to find A union B. So while writing A union B, first of all you write the elements which are present in the set A. A, B, C, D, U symbol, C, D, E, F. First of all, my sincere advice is here, better you recognize what are the common elements in both the sets. C is a common element, D is also common elements. Anyway, here C and D were repeated for two times in both the sets. Even though they are repeated for twice, we don't want to write two times. We should consider them, while writing answer, we should consider them as for one time only. So here A and B are present in only A. E and F are present in only in B. C and D are present in both the sets. Once again you go through this statement, which are either in A or in B or in both. If the elements are in A, we take out them. If they are in B, we should consider. If the elements are containing in both the sets, again we should consider them. So to combine all the elements. So first of all, write from here. What are the elements which are in A? Only in A. Only A elements are A and B. Both. What are the elements in both? C, D. So C and D writing for one time. Next, in B, what are the elements which like only B? E and F. Did you understand? The elements which are present in A or in B or in both. All the elements we consider for one time, and we should write all the elements as the A union B. Is it clear to all? Right. Next you see difference of two sets. If A and B are two sets, then their difference A minus B is defined as A minus B is equal to x set of all x such that x is belongs to A and x does not belong to B. What are the elements under A? That elements only we should consider after cancelling the common elements in both the sets. What are the elements are left in the first set? That elements only comes under A minus B. That's why here I am writing clearly. X must be belonging to A, they never belonging to B. Even though some elements are left in the set B, we don't want to consider them. We should consider the elements which are left in the first set only. In the same way, when we are doing B minus A, x says that x must be belonging to B, but that should not comes from A. Let me explain one example here. Here A is equal to set of all 1, 2, 3, 5, 4, 5, 5 elements are here given. B is equal to 1, 3, 5, 7, 9 and 5 elements are given. Here we are asking to find what is A minus B and B minus A. Let us see the solution. A minus B means 1, 2, 3, 4, 5 minus 1, 3, 5, 7, 9. When we are doing subtraction of two sets, first of all, the immediate action what should we do is recognize what are the common elements and immediately you just cancel them. See, 1 is a common element, so strike off in both the sets. 3 is a common element, you strike off from both the sets. 5 is also a common element, you strike off in both the sets. See, after doing the cancellation of the common elements, we get 2 and 4, only 2 elements are left in the first set. 7 and 9 are left in the second set. But here clearly I wrote here. A minus B means set of all x's that x is belonging to A and x does not belonging to B. Even though we left some elements under B, we don't want to consider them. We consider what the elements are present in the first set only. So here the elements are left in the first set is 2 and 4. This is A minus B. So similarly, you may guess what is B minus A by without writing the complete solution. From this you can guess easily. We can do the cancellation for the common elements. What are the elements which are present in B minus A? X must be belonging to B, but that never belonging to A. What are the elements are left in the set B here by doing cancellation? 7 and 9. So B minus A elements are nothing but 7 and 9. Can you say here A minus B and B minus A is equal? No. Therefore, we conclude that A minus B is never equal to B minus A. So today what we discuss here, union of sets and difference of sets. But here one thing, A union B is nothing but B union A. Combining means both the sets, both the elements of both the sets should be combined. So that's why here one thing is clear. I did not write on blackboard. A union B is nothing but B union A. But while doing difference of two sets, we never expect we may get the same elements for A minus B and B minus A. Is it clear to all? Note down the two definitions. Okay, children. Just now only we have discussed about difference of two sets. Means how do we subtract A minus B and B minus A. While subtracting A minus B, we came to know the elements which are left in the first set only should write as in the answer. In the same way, what the elements are left in the set B, those elements we write in B minus A. And here, let us see some important points we need to remember. There will be a chances to ask, even though these key points are not points in the examination point of view as half marks. So we may expect this. Let us see these points. First one, A minus B is not equals to B minus A. Of course, we might have observed in the previous class. A minus B is not equal to B minus A. Next, the sets A minus B, B minus A intersection B. in the above example, you might have noted no, in your CWA. So once you can go through that example, A minus B elements are only A and B. Common elements are C and D. B minus A elements are E and F. These three are mutually disjoint sets. So this point is very, very important according to my knowledge. The sets A minus B, B minus A and A intersection B are disjoint sets. Let us see the third point. A minus B is said to be a subset of A and B minus A is said to be a subset of B. Actually, if you go through the above example, in the set A, we have four elements A, B, C, D. When we find A minus B, first we strike off the common elements C and D. And finally, we get A and B is the answer for A minus B. So from that example, we came to know A minus B is said to be a subset of A. Even though B minus A is said to be a subset of B. Here you see, if A minus 5 equal to A minus A equal to 5. Here you may get a doubt, sir, how can you say A minus A equal to 5? Usually x minus x is equal to 0, 2 minus 2 equal to 0. That condition is true only when the elements are given. But not under, we don't want to consider that type of explanation under sets. Here you see the explanation for these two examples. For example, A is equal to set of all 1, 2, 3 and null set means there is no common elements. When we are writing A minus 5, 1, 2, 3 minus a null set. While doing subtraction of two sets, we know first of all we would like to strike off the common elements. Here nothing is there to strike off any common elements. Yes or no? So simply we leave the second set as usual. So what the elements are left in the first set, all the elements comes under the answer. That means if A minus A 5 equal to A. In the same way you find A minus A. A minus A. When we find A minus A, you see in the set first set A, set of all 1, 2, 3 minus again set of all 1, 2, 3. Do the cancellation. 1, 1, 2, 2, 3, 3. What elements are left in the first set? There is no element is left in the first set. That's why that answer becomes a null set, but that value is never equals to 0. Okay. And next, the definition is a singleton set. A singleton set. Let us see the definition. A set having only one element is called single element. That means there is a set. In that set, we don't have 2 elements or 3 elements or 10 elements or 20 elements. We just have only one element. That means a set which is consisting of only one element is known as a singleton set. Let me give an example for a singleton set. Here you see, P is the set of even prime numbers. There is a set P. P is the set of even prime numbers. That is, P is equal to set of all 2. Actually, prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 and so on. We know very well. What are the examples for prime numbers? Apart all the prime numbers, how many even numbers do we get? Only one even number we should get under prime numbers. That's why even prime numbers are only one number, that is only 2. So that's why set of even prime numbers is said to be an best example for singleton set. And next, equal sets. Equal sets have same elements. E is the set of letters in the word F. Equal sets means what? Equal sets have same elements. For example, 2 sets will be there. Under those 2 sets, they may have the same elements. Let me give an example. Here, E is the set of letters in the word E-A-R-T-H. Earth. Earth is a word. From that word earth, we are asking to write to prepare a set E. E is equal to E A R T H. We should separate them by using commas. E comma A comma R comma T comma H. So now E is a set with these letters E A R T H. And there is another set H. H is the set of letters in the word heart. H-E-A-R-T, heart. Now, how do we represent the set H? H is equal to set of all H-E-A-R-T. If you observe these two examples, E is equal to E-A-R-T-H. H is equal to H-E-A-R-T-H. See, E is present in both the sets, A is present in both the sets, R is present, T is present, and H is also present. So, unfortunately, even though the two words are different, what are they? At and heart. By converting them as sets, we came to know the two sets consisting of same elements. Then the two sets are said to be equal sets. And next, equivalent set. Last definition is equivalent sets. Equivalent sets have different elements but have same number of elements. Not like equal sets. Equal sets, they must have the common elements, same elements in both the sets. But equivalent sets means, here you see one example. There is a set F. F is equal to set of all 1, 2, 3, 4, 5. H is equal to set of all H-E-A-R-T. If we write cardinal number of a set for F, n of F is equal to, there are 5 elements. And what is the cardinal number of the set H? N of H is equal to 5. Even though these two sets, they don't have the same elements, but they have cardinal number of elements are same. They have same number of elements. That's why F and H are said to be equivalent sets. So there is a variation between equal sets and equivalent sets. Okay, is it clear? So today what we discuss now present singleton set, equal set and equivalent sets. So today apart union of sets, difference of sets, singleton set, equal sets and equivalent sets, all these definitions today we discuss. Is it clear to all? Is there any doubt to anyone? Okay, is there any doubt? Means better you note down the notes which was given to you. Note down all the definitions. Did you all note it down, those definitions? Okay, today I am giving some homework. Please note down the homework. Here first one is, there are two sets are given. A is equal to set of all 2, 5, 6 and 8. B is equal to set of all 5, 7, 9 and 1. 1 is given at the last. Remember, this is not 11, that is 1 only. You are asking to find A union B. Second question, let A is equal to set of all A, E, I, O, U. This is I. Of course, these are vowels, set of vowels. And B is equal to set of all A, I, U. What we are asking? We are asking to show that A union B is equal to A. So A union B answer is nothing but A only. That one we are asking to show. Here 4 sets are given. What are the 4 sets? Once read. A is equal to set of all 3, 6, 9, 12, 15, 18, 21. These are nothing but, what did you understand here? 3, 6, 9, 12, 15, 18 and 21. These are nothing but the multiples of 3. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21. These are the 3 multiples are given. And here you see B set. 4 multiples are given. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20. Until first 5 multiples. Here until first 7 multiples only given. And here C is nothing but the set of 2 multiples up to 8. First 8 multiples are given. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14, 2 8s are 16. These are the multiples of 3 until 7. These are the multiples of 4 until 5. These are the multiples of 2 until 8. and D is another set 5, 10, 15, 20. These are the multiples of 5 until 4. So from these 4 sets we are asking to find the difference of 2 sets. So what are the difference of 2 sets? A minus B you find separately, B minus C, C minus B, D minus B and A minus B. So these questions you do based on difference of 2 sets. You know very well when we are doing A minus B, first of all whether is there any common elements are present or not you consider. If is there any common elements are present, let us cancel them from both the sets. And finally, while writing the conclusion of A minus B, don't forget to write what are the elements which are present in only the first set. We don't want to consider it at any cost the elements which comes from the second set. We don't want to consider the elements which comes from the second set. We consider only the elements which are left in the first set. So these things please try to keep in your mind while doing the solution. So definitions are very, very important. Without theory part, mathematics application is impossible. Don't expect mathematics means only sums, problems like that. So to do each and every problem, there will be a theory part is very, very essential. Is it clear to all? So while doing the sums blindly, if you are doing without any idea, it may get some bad result. So that's why while doing subtraction of 2 sets, you remember that while subtracting 2 sets, let us consider the common elements in both the sets. First you have to strike off them. Then while writing the conclusion, you must write only the elements which left from the first set. That elements only we consider as the conclusion. We don't want to take second set elements. If suppose they are disjoint sets, there is no common elements. So we simply leave the second set and we consider all the elements from the first set as the answer. Now you go to the fourth question. State the reasons for the following. Here actually it was given in the question. These 2 sets are not equal. We are not asking some questions based on equivalent sets. We are asking some questions to practice, to get practice based on equal sets only. Here we are only giving these 2 sets are not equal. Sir, you are only saying no sir, they are not equal. What should we do? You should do why, justify. What is the reason why the two given sets are not said to be equal? Here you see set of all 1, 2, 3 and so on 10. From LHS part, we consider the natural numbers 1 to 10. First 10 natural numbers we consider under LHS condition. While RHS condition, if you observe, LHS condition which was given in terms of roster form and RHS condition in all the 4 cases you see once. Let us see once. In all the 4 cases, right hand side conditions are given in terms of set builder forms. LHS conditions are given in terms of roster forms. But they are saying these 2 sets are not equal. Why they are not equal? You must observe the some small mistake will be there. So that mistake you find out and that can be written as a solution. So that is the reason that those 2 sets are not said to be equal. X says that X belongs to natural numbers, but X value lies in between 1 and 10. You might have understood about my explanation. X value which lie between 1 and 10 means here 1 and 10 should not include. You might have noticed. And second one you see set of all 2, 4, 6, 8, 10. This is a set is not equal to X, set of all X such that X is equal to 2n plus 1. While substituting X is equal to natural numbers here. Here n is equal to 1, n is equal to 2, n is equal to 3. Any natural number you can substitute. But anyway, while substituting some values instead of RHS, we may get some answer. That means here my sincere advice is while doing each and every problem from the 4th Roman, let us convert the RHS condition in terms of roster form. Then try to equate whether the RHS condition is said to be equal to the left hand side condition or not. If they are not equal, then you came to know what is the difference of both LHS and RHS. Why they never equal? What is the reason? What elements are left? So the particular reason you may identify. Third question you see 5, 15, 30, 45. These are the 4 elements are given under LHS condition. And in RHS condition, x says that x is a multiple of 15 is given. If you observe, you came to know whether that all given numbers are multiples of 15 or not. Easily you can recognize, easily you can justify. Fourth one is set of all 2, 3, 5, 7, 9. X says that x is a prime number. Why this set and this set are not getting equal elements? What is the reason? Some reason will be there. How do we recognize them? By converting 4 RHS conditions in terms of roster forms. Is it clear, Amma? Are you able to do these 4 questions as homework? So once just we recognize what the topics would we discuss today. So at first in the morning, today's class we discuss about union of 2 sets definition. Union of 2 sets. That means by combining the elements of both the sets A and B, then the answer comes as A union B. And next difference of two sets, A minus B, B minus A. Even though we know A minus B is not equals to B minus A by doing some examples also. Then we have seen some key points, some 4 or 5 points I wrote on blackboard. I told you, please focus on those points. They are very useful for you even in the examination point of view. There is a chances to ask those questions comes as half mark questions. Okay. And next we discuss about singleton set definition. Next we have seen about equal sets and equivalent sets. Equal sets means 2 sets are said to be equal sets. They must have the same elements. Both the sets they must have the same elements. But while writing equivalent sets, we never expect the same elements, but they may have the same number of elements. That means in both the sets, cardinal number of elements must be equal. So except equivalent sets, remaining all the definitions, even from singleton set also did not give. Except equivalent sets and singleton set, rest of the all definitions today I gave some problems. Is it clear to all? Okay, ma, note down the homework and do each and every problem without copying from any one of the HWs. If you have any doubt, you are unable to do solution for any problem, tomorrow you remind me, I will explain to you. Okay, thank you, have a nice day.